Hiya, how's it going? I'm in my classroom today, okay? This is the end of the day, hence I'm all dressed up in my normal teaching gear. Except for this, I don't normally wear this kind of, you've got lucky there, I just put this on this morning just for a change, all right? Main reason I'm in my classroom is because I want to use a lot of board space, and I've got my interactive whiteboard because it helps me with the diagrams, and because I'm dealing with circles and triangles I don't really want to be drawing them freehand. I could do, but as a presentation that's going out on YouTube I kind of want it to look good. I don't want people to tune in and see some funny looking diagrams, okay? So a couple of reasons why I'm in my classroom today. Now, I'm going to start off with a really interesting fact that's going to blow your mind away. Okay? I still find it absolutely fascinating. Take any triangle, such as the one I've drawn there, pre-prepared for you. Take any triangle you want. Here's the fact. It's always possible to draw a circle through the three vertices of the triangle. Always possible. Okay? That always blows my mind away. Try it, okay? It's a bit difficult, okay, but it's always possible. You can always do it. All right? Consequently, it's always possible to draw a circle through any 3 points. Okay? Think about that. Because it's always possible to join any 3 points together to make a triangle, isn't it? Because a triangle is always made up of 1, 2, 3 points, 1, 2, 3 vertices. So it's always possible to draw a circle through any points. The circle, by the way, is unique. You can only draw one circle through the 3 points. It's unique. Okay? Let's just have a look at that. That circle is called a circum circle. You can circumscribe shapes. Okay, that is certain polygons. It is possible to draw a circle through the 3 vertices. With a circle, you can always do it, but with some shapes, it's not always possible. Okay, with regular shapes, for example, regular pentagon, regular hexagon, yeah, it's possible. Incidentally, that's what Archimedes did. Okay, he drew shapes. Regular polygons, and he drew a circle outside the shape and a circle inside the shape. That's kind of one of the ways he used to try and evaluate pi to as many decimal places as possible. I'm not here to talk to you about pi, okay? That's something else you can research if you want to, okay? You've seen this before, probably, if you did GCSE. Do you remember the cyclic quadrilaterals? Same sort of thing going on there. That is, you've got a circle that's circumscribed around a quadrilateral, okay? But I'm here to talk to you about triangles, okay? Now, how do we go about showing that it's possible to circumscribe a circle? How's it possible to show that you can possibly draw a circle around the 3 vertices? Okay. Well, what we're going to do is we're going to start right at the beginning. Here's the 3 points. I've labelled them A, B and C. And then here's the triangle. And what we're going to do is we're going to look at the perpendicular bisector of each of these 3 edges of the triangle. Alright, so the first one coming up here. Alright, and just see you have to construct these using ruler and compass, didn't you? If you want, go ahead and do it. Just draw any 3 points, join them together to make a triangle, and then do the ruler compass constructions. Okay, I'm not going to, you just have to take my word for it, but that's a perpendicular bisector of BC. Okay, then I'm going to do another one. There, that's the perpendicular bisector of AB, and then I'm going to do another one. Okay, perpendicular bisector of AC. What do these blue lines have in common? Well, apart from them all being perpendicular bisectors, notice they all cross through one point. They cross through that point. You can probably guess what that is going to stand for, can't you? Yes, you got it. It's the centre of the circle. Okay, it's the centre of the circle. And if I put the circle in, there we go. Now, how's that working? Do you remember the circle theorem involving perpendicular bisectors? Possibly, possibly not. Well, let me just take a couple of them away for you. That one there. Maybe I'll put them back again in a minute. And that one there. Now, this here is called a chord of the circle, point BC. If you were to construct the perpendicular bisector of that chord, it goes right through the centre. Okay, it goes right through the centre. So, what that means is, if we look at this chord here, from A to C, the perpendicular bisector of this chord also goes through the centre. Okay? And same with this one. Okay? The chord AB, perpendicular bisector, it goes through the centre. Okay? So because in reverse, if I have the circle to begin with, if I have the chord AB and the chord BC and the chord AC, all of those perpendicular bisectors must pass through the centre of the circle. So in reverse, you can see why the general result I showed at the beginning is that it's possible to draw a circle that passes through all three corners. It is unique, and the reason it's unique, of course, is because these perpendicular bisectors, they're only going to cross through one point. You can't have three perpendicular bisectors, of course, passing through multiple points. Only pass through one point. Okay, so it's only possible to do it once. Okay. Now you need to remember that fact for some of the A-level mathematical questions that are going to be coming up. Okay, some examples coming up after this, but you have to remember that mathematical fact. Okay. Here's another one for you. Okay, I've drawn a different triangle this time. Suppose it's a right angle triangle. So let me just illustrate that by right angle. Okay, but I'm just going to take it away again, because sometimes a question is posed where you've got to show that or prove that it's a right angle triangle. Okay, if it is a right angle triangle, the consequence is that PQ is a diameter. You probably saw that as a circle theorem when in year 10, year 11. Remember the circle theorem? The angle in a semicircle is a right angle. Well, of course, if that is a diameter, then this is a semicircle, and the angle in that semicircle there is a right angle. Okay? But in A-level mathematics, we look at it rather differently. Okay? We say that if PQ is a diameter of a circle, then the consequence is that that angle called PRQ must be a right angle. Now I've written here two different results. Okay? PQ is a diameter if and only if the angle PRQ is 90 degrees. Have you seen that symbol before? Maybe, maybe not. Well, the if and only if symbol is basically implies and is implied by. It basically means PQ is a diameter implies that PRQ is 90 degrees. As I said, if PQ is a diameter, it implies that's 90 degrees. It also works the other way round. Okay? If PRQ is 90 degrees, this will imply that PQ is a diameter. You need, in A-level mathematics, to be able to use the two results. Okay? You need to use right to left and left to right. Also, okay, if PQ is a diameter, then the gradient of PR multiplied by the gradient of QR is -1. Okay? Think about that for a minute. The gradient of that line multiplied by the gradient of that line. If the product is -1, that means the lines must be perpendicular. And if these two lines form part of a triangle, if they're perpendicular, then the hypotenuse, okay, must be the diameter. Okay. Again, from left to right, PQ is a diameter will imply the gradients multiplied to get -1, and from right to left, if the gradients multiplied to get -1, then you can infer from that PQ is a diameter. Okay. So a couple of important results in this part of the mathematics course. There's some examples coming up now, two of them in fact, that I'm hoping that you're going to find interesting. Okay, using some of these mathematical facts. Okay. Stand by. So this is the first example I'm going to go through with you. I've drawn a diagram just to save me writing down stuff on the board. Basically the wording is the diagram shows a circle with points A, B, C as shown. Okay? So the coordinates of A are -8, 1, B 4, 5, C is -4, 9. But let's repeat, in this particular example, the diagram is part of the question as well. What you need to do is answer parts A and B, show that AB is a diameter. So obviously it looks like it's a diameter, but looking like is not the same as being able to prove it's a diameter. So you've got to show that AB is a diameter of the circle, and then you've got to find the equation of the circle. Okay? Pause the video, have a go at it, and then just unpause it, see how you get on, or just work through with me. Okay? So showing that it's a diameter, you've got two choices really. You've got one of two things you can do. You can either do it using gradients or use Pythagoras Theorem. I prefer gradients personally, just because it's quicker. It's a lot quicker than using Pythagoras Theorem. And we only need to do two calculations. That is, we find the gradient of that line there, that chord, AC, and we find the gradient of that chord there, BC. Okay? I'm hoping you appreciate why that works, because we need to use the rule that the gradient of one line multiplied by the gradient of a perpendicular line, the product of the gradient should be -1. As long as that works out, then that will prove that these two are perpendicular. Okay, so let's just do that. So the gradient of one line, AC, should be 2. Let's just check that. So from A to C, so you've got between -8 and -4 and 1 to 9. Difference in Y coordinates is 8. Difference in X coordinates is 4. Okay, and then 8 divided by 4 gives you 2. Okay. And then the gradient of the other line, you should get -1/2. You should get -1/2, okay? Just bear in mind, just to show that question, it's not really enough just to write them down. You should show some working. I'm just talking you through it and giving you the highlighted answers. So from B to C, first of all, you can see it should be a negative gradient from the diagram shown. But when you do 5 subtract 9, you get -4, and then 4 subtract -4 is +8, okay? So -4 divided by 8 gives you -1/2. And then what you need is a conclusion. I suggest this as your conclusion. AB is a diameter. Write down what it is you've been asked to show. Since, and then 2 multiplied by -1/2 gives you -1. Okay, and that's enough. Okay, so you see, there's not really much there to do in terms of working. An alternative is to use Pythagoras Theorem. Okay, that works by working out the length of each of these chords and the length of this line here. I call it a chord because we don't really know at this stage whether it's a diameter or not. Okay, so you've got to show that squared plus that squared equals that squared. So 3 calculations you need. Okay, so the first one I decided to do was AC. Okay, so from A to C, work out what that is. You need to use Pythagoras Theorem in each case. So you've got difference in y coordinates is 8. So 8 squared is 64. Difference in x coordinates is 4. So that's 16. 64 plus 16 gives you 80. Next, I worked out BC squared. So BC squared, so difference in y coordinates is 4. Difference in x coordinates is 8. So same again, 16 plus 64 gives you 80. And then you need to be getting this result here. Again, because it's a show that, it's not enough just to write down that, because you can deduce that if those two are 80. Obviously you're looking for the sum to be 160. You should work it out, okay? So the working for it is between A and B. Difference in y coordinates is 4, so you've got 16. And the difference in x coordinates is 12. 12 squared is 144. 144 plus 16 gives you 160. And then your conclusion, something like this. Again, write down what you've shown. AB is a diameter, since, and then AC squared plus BC squared equals AB squared, okay, because this plus this equals that. So either approach is fine for this. Okay. Moving on, find an equation of the circle. 2 things you need, of course, the radius and the centre. How to find the centre of the circle? Well, that's going to be the centre of the circle, isn't it? Can you see that's the midpoint of this diameter, which is midpoint of AB. So the first thing you do is work out the midpoint of AB. That's quite easy. Of course, just work out the sum of the x coordinates divided by 2. So 4 plus -8 is -4. Divided by 2 is -2. And then sum of the y coordinates divided by 2. 5 plus 1 is 6. Divided by 2 is 3. So quite easy to do, of course. And then you ought to work out what the radius is effectively. They don't really need to know the radius, you just need to know r squared. Because remember, the equation that we're dealing with is x something, y something, and r squared. Okay, so x plus minus something. You can fill out this bit already. Okay, the x plus 2 squared plus the y minus 3 squared. It's just the r squared bit. That's what I'm getting at. Okay, so let's just add a little bit to my diagram, show you. So if that's the centre there, you need to work out what this bit there is effectively. I'll just label it as r. Okay, so you've got difference between that and that is 6. So 6 squared, 36. Difference between that and that is 2. So 2 squared is 4. So 36 plus 4 is 40. So r squared must be 40. You don't need to do the square root of that, because obviously the question doesn't ask you for the radius, just ask for the equation of the circle. So here we go, that's our final answer there. I'm hoping you found that useful. Next example is coming right up. Right, let's look at the next example, shall we? So points P, Q and R with coordinates 3, 16, 11, 12, -7, 6. They all lie on the circumference of a circle. You're given the equation of the perpendicular bisector of PQ, and that's y equals 2x. You need to find the equation of the perpendicular bisector of PR, find the centre of the circle and work out the equation of the circle as well. My suggestion is you just pause the video, have a go at these and then unpause it, see how you get on. Or just pause, do part A, unpause, see how you get on, then B and then C, or you just work through with me, that's completely up to you. But just bear in mind, I'm about to start to go through this solution right now, okay? Right, first off, maybe a good idea just to draw a quick sketch, okay? A quick sketch of what is going on, because with coordinate geometry or vectors or even mechanics, it's always a good idea to have a diagram. If you've got a diagram, you can more easily understand what is actually going on and what it is you need to do, okay? So what I've done is I've drawn a circle here and I've put it in positions of points P, Q and R. For the moment, they do not have to be accurate, okay? Just loosely speaking, put in P, Q and R, okay? And then see what you can do from that. Now we're told the equation of the perpendicular bisector PQ is y equals 2x. So what does that look like? It looks like this. Okay, so there's the chord from P to Q, and this here I've drawn in as a perpendicular bisector, and we're given the equation of that line y equals 2x. Okay, we're probably going to have to come back to that a little bit later. Not now, because now we're asked to do the equation of the perpendicular bisector of PR. So P to R, we've got to do that. Maybe a good idea just to do a quick diagram of what that looks like. Okay, if you end up drawing several diagrams, fine. Okay, it's fine. This is not an exam, okay, so you've got some time, okay? The best thing is you understand it first, right? So that's the chord PR, that's the perpendicular bisector. Our job then is to work out the equation of this blue line, all right? If that's giving you more of an idea of what to do, maybe pause the video now and have a go at it. Otherwise, again, just keep on going with me, okay? Right, what you need to do is you need to work out the midpoint from P to R. Okay, and then that gives you the coordinates of that point, and what you also need to do is work out the gradient from P to R, because remember, once you've got the gradient of P to R, because this is perpendicular, you can find the gradient of this line there. Okay, so first off then, midpoint is -2, 11, hopefully that's straightforward. -7 plus 3, okay, is -4, divided by 2, gives you -2, okay, and then 6 plus 16 is 22, divided by 2. That gives you 11, so the midpoint there is -2, 11. Right, next up, gradient of P to R is 1. So changing y coordinates, 16 over 6 is 10. 3 subtract -7, 3 plus 7 is also 10, so 10 divided by 10 gives you 1. And then the gradient of the perpendicular bisector we want, of course that's got to be -1. I usually use m to represent the gradient, okay, because we're going to use the equation y minus y1 equals mx minus x1, and obviously then m is what I'm going to substitute in there. So we've got the coordinates of the midpoints, we can just substitute those in, and this will be our equation. So y subtract 11, and then equals -1, x subtract -2, and then we just rearrange it, write it in a slightly better form. Y equals -x plus 9, okay, so that's it. Right. What I've done is I've just drawn it on with what we had before, okay, y equals 2x. I did say we'll have to come back to that later, okay. So find the centre of the circle. That's clearly, I hope, where these two blue lines cross, okay, where y equals 2x meets y equals -x plus 9. Why is that? It's because the perpendicular bisectors meet at the centre of the circle. Remember that rule? Okay. You kind of need to remember all these things so that the question can be answered. Okay? So the perpendicular bisectors will meet at the centre of the circle. We're going to find where these two lines intersect. Well, it's pretty easy, particularly since they're given in the form y equals something. So you've got to solve this equation. 2x is equal to -x plus 9, and that just gives us x is equal to 3. I'm hoping you're happy with rearranging and solving that. Okay? And then the centre is 3, 6. Because if you just substitute in x equals 3 into either that one or that one, you get a y coordinate of 6. Okay, so that's that. And then the equation of the circle, almost there really, aren't we? Almost there, because we've got the centre, 3, 6, so we're going to hang on to that. We just need to find what the radius is, because so far we can write down this, can't we? Yep. We can write down x minus 3 squared plus y minus 6 squared equals, we're just missing what the radius is. Okay. Well, the radius, well, it's your choice really. You've got to work out either this distance from the centre there to Q, or this distance there. It's up to you, okay? Maybe you just have a go at working out that distance there. all right? And that will give us our radius, okay? Well, that distance is quite easily done. You get, what's that going to be, 3 to 11, so that's 8, so 8 squared, and then the y coordinates 6 to 12, that's 6, so 6 squared. 8 squared plus 6 squared is 100, okay? You don't really need to square root it, okay, because remember the equation of the circle is equal to r squared, so okay, the radius might be 10, but actually you don't need to square root it, just keep it as 100, and then that's it. Your equation, x minus 3 squared plus y minus 6 squared equals 100, okay? Well, I'm hoping you found that useful. I'm hoping you found these examples in this video helpful to you. The next thing to do, of course, is practice as many questions as you can. Okay? Hope they go well for you. I'll see you again.